Hello everyone, welcome back to the channel. If this is your first time here, please like, subscribe and share. In our previous lessons, we discussed Ohm's law and factors affecting resistance of a conductor. One of those factors is the type of material. That is what we are going to discuss today. Now you may ask, why does copper conduct electricity more than iron, even when they have the same length and the same thickness? The answer is a property known as resistivity. Resistivity is a property of a material that determines how strongly the material opposes the flow of electric current. In a simple term, resistivity tells us how good or bad a material is at conducting electricity. Now, resistivity is represented by the Greek letter rho. Rho. This is the symbol. It stands for resistivity. Each material has its own resistivity value. That is why copper is used for wiring, rubber is used for insulation. Right. Based on resistivity, materials are grouped into three. The first one, number one, is conductors. Conductors. Example of conductors, we have copper, we have aluminium. Then number two, semiconductor. Semiconductors, example, we have silicon, we have germanium, Then number three is insulators. Example, we have rubber, we have glass. All right. Now, mathematical relationship is R is equal to resistivity multiplied by length all over area. Now, in our previous lesson, I told us that resistance is directly proportional to the length and inversely proportional to the cross-sectional area, or you call it thickness. So now here it means that resistance is equal to resistivity multiplied by length all over area. All right, we are going to take example. Let's look at example. Example. A copper wire has length L is equal to 2 meters, cross-sectional area is equal to, cross-sectional area in bracket A is equal to 1 times 10 raised to the power of -6 meter square. Note that area is measured in square meter. Then resistivity of copper is Here is 1.7 times 10 raised to the power of negative 8 ohm meter. I proved that. I told you resistivity is measured in ohm meter, and from the formula R is equal to resistivity times length all over area. I proved that. So if you don't understand that, go back to our previous lesson and watch. All right, look at the questions again. Because a copper wire has length L is equal to 2 meters, cross-sectional area is equal to 1 times 10 raised to the power of negative 6 square meter. Resistivity of copper 1.7 times 10 raised to the power of negative 8 ohm meter. All right. So solution. You write down the formula first. No, if you are solving any problem in physics, you write down the formula. As I told you earlier, that you don't need to quote anything, you don't need to memorize anything. All you need is understanding. Just understand. So here you write down the formula that R is equal to resistivity multiplied by length all over area. Now, what you should do is very simple. For you to substitute those values, once you understand that length is measured in what? Meter, that area is measured in square meter, the resistivity is measured in ohm meter, just substitute the values to this formula and you get your answer. As simple as that. Now look at what I'm going to do here. Now from the question there, the resistivity is given as what? Right here equal to is given as 1.7 times 10 raised to the power of negative 8. Then multiply by length is given as what? 2 meters. So multiply by 2 all over 1 times 10 raised to the power of negative 6, which is the cross-sectional area. All right. From here, you write here that R is equal to, multiply this 1.7 multiplied by 2. That will give you 3.4. Then you bring down this times 10 raised to the power of negative 8 all over this 1 times 10 raised to the power of negative 6. All right. Now look at this. What should you do again? Okay, you see that you have 10 here as the base, and you also have 10 here as the base. From indices, know that when this 6 now comes up here, it becomes positive, because here it's negative, right? So you write it here as what? Positive. So here you have that R is equal to 3.4 multiplied by 10 raised to the power of negative 8, rather negative 8 plus 6 all over 1, which is this one here, and that is equal to 3.4 times 10 raised to the power of negative 2. Now when you divide this by 1, you have this. And what is the unit of resistance? Is in ohms. So this is the answer. This can as well be written as, here you have negative 2. It means that you have what? If you want to remove this exponential, you move this decimal point 2 times to your left. So that will give you 0.034 ohms. That is the resistance of that copper, of the copper cable we are talking about here. Look at how small is this value. That is why copper is a good conductor of electricity. So if you understand this, it will help you. So all you need to do is that follow it step by step. If there is any area you don't understand, please go to the comment section and ask question, or what you need to know more here, or you need more example, or there's any question here that you need to know that you've been trying to understand, it looks difficult, just let us know. If you found this helpful, please like, subscribe and share. Thanks.